Now we're actually starting on the pre-calculus material, beginning with Chapter 1, Section 2 in our book, which we will break into several sections. Our goal for this lesson is to learn how to determine what is or is not a function, and then to describe things like the domain, range, or asymptotes of that function. One common application of this that you could see in life would be things like me creating a seating chart, where I take elements from the domain, the students namely, and then match them with certain elements from the range, which would be the desks in my classroom. So here's our official definition of a function. It's a rule that takes numbers from one set, the x values or the domain, and assigns them to numbers from a different set, which we call the range or the y values. And this defines a relationship between the x's and the y's. Now, to determine if something is a function or not, the important rule here is that you can have two different x values attached to the same y value. So for example, you could have the coordinate 2, 3 and 5, 3, but you could not do it the other way around. You can't have a single x value with two different y values. For example, 2, 3 and 2, 8. That would not be allowed, having one x with two different y's. Here's what one of the questions will look like based on that information in your math lab assignment. The first part will say, is this a function? Well, I see x equals -5, x equals 9, x equals 2, and x equals -8. Since none of the x values are repeated and assigned to two different y values, it is in fact a function. Next, they're going to say, what is the domain? Well, the domain is the x values of those ordered pairs, and they could give you the order in a couple different ways. They might give it to you the way they're presented. Me personally, I usually like writing them in order from least to greatest, but since it's multiple choice, you just have to find what they are using. So in this case, the x's are -5, +9, +2, and -8. And it looks like they listed them in the order they were presented right here with the third option. The last part of the question is going to be very similar, but when they ask for the range, they want to know what y values do you have. So focusing on the second number in each ordered pair, there's -6, -8, +2, and then -8 is repeated, but you shouldn't list it twice in your answers. So don't include repeated numbers. So my answers are going to be -6, -8, and +2, which looks like this second option. Sometimes you'll be asked to identify if you have a function graphically, and you'll probably remember this from algebra as something called the vertical line test, which is basically saying that if you can draw a vertical line in the graph so that it touches the function multiple times, then it fails the vertical line test and it is not a function. But here, everywhere I draw vertical lines, the graph looks fine. On this one, everywhere I draw vertical lines, the function looks fine. On this one, I can see some locations where if I draw a vertical line, it crosses the shape of the graph here, here, and here. Since it crossed my vertical line multiple times, we say it has failed the vertical line test, so this one is not a function. So this one would be yes, yes, a function, and then this one would have been no, not a function, because it failed the vertical line test. The last set of rules I need to give you guys is for doing this more algebraically, determining the domain and the range. For finding the domain, you're looking for what x values are allowed. Now, whether it's algebraically or graphically, basically you're just trying to say, are there any places that the graph or the function can't have a certain x number? For example, if you have a negative value inside of an even root, like a square root or a fourth root or a sixth root, it doesn't matter for the odd number roots, like third root, fifth root. So if you have any negative values for x inside of an even root, then those are restricted from the domain. Or if you have a fraction and there are any values for x that would make the denominator equal 0, then those numbers are restricted from the domain. Otherwise, you include all of the x values. So from looking at the equation, just look for those two things. If there isn't a square root and there isn't a fraction, then the domain should be all real numbers. That's what you assume otherwise. For the range, you're going to be looking for the y values, and usually the range is only asked based on looking at the graph of a function. There are some ways to find it algebraically, usually by looking for horizontal asymptotes, but there are some problems with that technique. So if they ever ask you for the range, you probably either want to graph the function or they gave you a graph and you're just going to be looking at that to find your answer. So here's an example of a function. I'm looking at the equation of it, not the graph, and they're asking what is the domain of this. Well, I don't see any square roots and I don't see any fractions, so I start off by assuming it's all real numbers, which mathematically we usually write as negative infinity to infinity. So in interval notation, this is saying every single number is possible since I don't have the restrictions of a radical or a fraction. Here's an example where again we need to find the domain. I don't have any radicals, but I do have a fraction. So I want to figure out which x values make the denominator equal 0. I don't care about the top being 0, I only care about the bottom. So I'm going to take the denominator, x squared minus 10x, and I'm going to set it equal to 0 and then solve this equation. One thing I notice is that I can factor out the GCF of x. Now these two things being multiplied together, x and x minus 10, since they're set equal to 0, I can solve them separately and find x equals 0 or x minus 10 equals 0, which means x equals 10. So there are actually two x values I'm not allowed to have. These are the values that make the denominator equal 0, but I can include any other possible number. So my answer in interval notation would be starting from negative infinity and going all the way until I hit the number 0, but then I can't include 0. And then I want to get the numbers in between 0 and 10. So I say from 0 to 10, but not including the endpoints. And then I have all of the numbers bigger than 10. So another union, 10 to infinity. It seems like a lot, but basically we've just said all of the numbers except 0 and 10. Here's a more difficult example because it includes both a fraction and a square root. I've already shown you that you need to make the denominator equal to 0 and solve. So I can say x plus 5 equals 0 and x squared plus 1 equals 0 separately because those two things are being multiplied. Now here on the left side, this is x equals negative 5, so that's one x value I'm not allowed to have. But when you look at this part, if you subtract 1 and then take the square root of this, you actually get imaginary answers. And we don't care about imaginary answers most of the time, so I'm not actually going to worry about them when I write out my domain. They don't exist in the real number line, so I can't restrict them from my real domain. So I don't have to worry about this part. However, I did indicate that we also have a square root. So for the square root, the problem is that whatever's inside can't be negative, which means I need the inside of a radical to be greater than or equal to 0. Well, if you're solving this radical, you would subtract 6 from both sides. And when you multiply both sides by negative 1, don't forget the special rule for inequalities that flips the direction of that symbol. So now I know that x has to be less than or equal to 6. So my requirement at this point is that I can only include numbers from negative infinity all the way up till 6. I don't have to worry about this part because they were imaginary, but I do have to cancel out negative 5 from being an answer. So to say all the numbers less than 6, that would be from negative infinity all the way up until I hit negative 5, and then I'm skipping negative 5, and I'm going all the way until I hit 6, which I'm allowing as an answer, so I will use brackets when I type that part in. Now you're going to have a few questions where they ask you for the range instead of the domain. To do this, it's helpful to have a graphing calculator So I'm going to show you a website that you can use in case you don't have a physical one. So the website is up here at the top, desmos.com/calculator. And when you use this, you'll be able to type whatever the function was directly into the line here, and it will draw the graph for you, which we'll use for reference. If you don't see the graph, be aware that you might need to zoom out or manipulate the window around in case the graph isn't right around the origin. And in this case, I can see that the graph was stopping here at -6, and then it goes down forever from there. So the way I would answer having the graph go as high as -6 and hit everything below it, I would say from -infinity up to -6. And in this case, it can actually hit -6 because that's found by plugging in x equals 0. So then y would equal -6. So since I'm including that answer, a bracket, and that's our range. Here's our last example for this section, and they're going to ask you to find both the domain and the range, and they have provided the graph for you. Do note that you can zoom in if needed, if you're having a hard time seeing exactly where the graph is ending for the x or the y values. So first they've asked us to find the domain. And from counting out the tick marks, the farthest to the left I see this graph hitting is -3, and it's going all the way over to +5. Now the fact that they used open circles here means they're not including those endpoints, so I know I need parentheses from -3 to 5. But that was easier to determine since this was just multiple choice anyways, and they weren't asking us to type it in. Next, they want us to state the range of the function. So now I'm going to be looking up and down. What's the lowest point of the graph? And it looks like that's -4, while the highest it ever reaches is positive, or actually just 0. There is no positive or -0. So the highest it's reaching is 0. And again, hollowed out circles, so we're not hitting either of those two numbers. My smallest number is -4. My biggest number is 0. And that's all for the notes today, guys. Thank you for following along.